Hello, my name is Ashley Lovano and I will be kicking off Group 3's presentation. Today we will be discussing the topic of should steroids and hormones be used in food animals. We do stand in being against the use of steroids and hormones, but will present both ends as to why some are for and others are against. Steroids and hormones are used by farmers to promote additional physical growth in their livestock. This is done to increase the quantity of production. They both vary, and in some cases, synthetic forms of steroids and hormones are used with livestock animals. To elaborate, this includes the use of synthetic forms such as estrogen and testosterone. Now, although these are recognized as natural hormones produced in human males and females, synthetic versions of these hormones being administered in livestock animals can be a raise of concern from a health perspective. Acknowledge that these are just the hormones we are aware of. According to the National Library of Medicine, both antimicrobials and growth hormones used for growth production in food-producing animals have provoked much debate on the safety of livestock products for human consumption. The NIH performed a research conduction unveiling the additional hormones used in cattle for growth production, including estradiol, progesterone, or synthetic compounds like zeranol. Now, these are just some of the substances that reach the surface. Now consider how much others are underlying beneath our knowledge. Estradiol is a primary hormone administered to cattle animals. Of the male and female population, we see this hormonal substance being given to the females. For example, a large portion of the American society preferably has a greater liking for the breast of a chicken in comparison to any other part of the chicken. In the animal food market industry, the producer acknowledges this factor learned by examining their consumers. Estradiol is recognized as a major helping hand as this hormone targets enlarging and inducing growth in breasts. Remember, better quantity equals more production. It's really important to ask though, do we know all there is to know about in regards to estradiol? The National Library of Medicine conducted a study where different doses of estradiol were administered to mice and rats, and the findings were quite remarkable. As a result of their study, the NIH concluded that increased incidence of tumors were found in the mammary and pituitary glands, the uterus, cervix, vagina, testicles, lymphoid organs, and bones. Now, before some debate, while this research was conducted on mice, how does that link to humans? The National Human Research Institute stated in an addressing to the public that overall, mice and humans share virtually the same set of genes. Almost every gene found in one species has been closely related form in the other. In addition, they stated the protein coding regions of the mouse and human are 85% identical. This goes to show why studies relating to the effects certain substances have on humans are conducted on mice due to their high similarity. So you might want to take a deeper look into your Tyson branded chicken in your fridge. Today, many gather to represent animals as a voice they do not have. Organizations like PETA, the People for the Ethical Treatment of Animals, and HSUS, the Humane Society of the United States, have exceptionally grown and are now identified as the two main organizations that proceed with involvement in the discussion of animal rights according to the textbook, The Importance of Animals in Our Society, written by Michael Thomas and Michelle Gansey. Additionally, it's significant to recognize that both of these organizations are vocal and engaged in the public arena, according to the textbook. In other wordings, these two main organizations pave the way for social involvement within society on a sociological matter. I will now pass it on to Samantha.
Thank you, Ashley. Hi, my name is Samantha, and this is our presentation on if hormones should be used in food animals. Ashley and I completed this project, and this one is in opposition of the use of hormones. History of cattle. Cattle were domesticated between 8 to 10,000 years ago per Britannica Encyclopedia and were considered an all-purpose animal. This means they are used or have been used for meat, milk, and as draft animals, as well as tools or leather. Cattle are well adapted for grazing and eating tough vegetation. This makes them useful for land management as well. Different breeds of cattle are bred for different things. Some are raised for milk, like a Holstein, and others are raised for muscle, like an Angus, that will later be processed for meat. Holstein cows are the typical black and white cows that most people think of, and Angus are black cattle. The image depicts different breeds of cattle. Why are cattle given hormones? When beef production became commercialized thanks to refrigerated railway cars, ranchers expanded rapidly. Now that the means existed to make the meat a profitable part of the animal, beef producers had to find a way to maximize this profit potential. In the 1950s, the first hormones were approved for production animals, and because cattle have the poorest conversion ratio, ranchers were eager to find ways to improve their profitable margins. By giving the cattle growth hormones, the cattle were spending less time in feedlots and were gaining weight faster. This meant the farmer could harvest more cattle faster to turn a larger profit. This also meant better beef prices in grocery stores for consumers. Beef cattle are often given steroid additives to increase growth and development. Common steroids include natural steroids like estradiol, testosterone, and progesterone, or man-made steroids from compounds. Animal impact. Unfortunately, little is known about the animal welfare effects of hormone growth promotants in cattle. Research tends to focus on production or performance characteristics rather than the animal welfare directly, per SPCA Australia. The injection site should be considered as well. There's a risk of infection at injection site, and with how much cattle move their ears, there is more chance for irritation and swelling. Another impact is the use of RBGH in dairy cattle. Cows treated with RBGH tend to develop more udder infections or mastitis. These cows are given more antibiotics than cows not given RBGH. This brings up a following question of, are we causing an antibiotic-resistant bacteria that may be harmful for not only the animal, but for the consumer? Consumer impact. In an article from Urology Associates, the author brings up two questions. The first is how much of these additives we absorb when we consume dairy or meat products. Do these additives simply pass through our digestive system, or does our body absorb them? How much remains in products after processing? The second concern is how these steroids or hormones affect the human body. Some hormones are specific to cattle, others are similar to hormones found in humans. Do they all impact levels of human hormones? The author determines that until there is more research produced, neither of these questions can be accurately answered. It was determined that BGH, bovine growth hormone, is not active in humans. So even if it were to be absorbed from drinking milk, this specific hormone wouldn't be expected to cause health effects. At the same time, there are some problems with the dairy cattle treated with this hormone. Per the American Cancer Society, of greater concern is the fact that milk from RBGH-treated cows have higher levels of IGF-1, a hormone that normally helps some cell types to grow. IGF-1 is an insulin growth hormone that manages the effect of growth hormones in our body. It promotes normal growth of bones and tissues. Growth hormone levels in the blood fluctuate throughout the day depending on your diet and activity levels, but IGF-1 levels remain stable. So, an IGF-1 test is a useful way to find out if your body is making a normal amount of growth hormone. Several studies have found that IGF-1 levels at high end of normal range may influence the development of certain tumors. Some early studies found a relationship between blood levels of IGF-1 and the development of prostate, breast, colorectal, and other cancers. Further research into this delivered inconclusive answers. Environmental impact. Beyond the effect of hormones in the animal and in people, more notably is the effect on the environment, something we all share. Unfortunately, growth hormone presence in waterways has been linked to adverse endocrine disrupting effects on aquatic and terrestrial life. These hormones were found to be from a nearby beef cattle production lot. Changes to fish in the waterways was noted, and a change in sex ratio and intersexualization. A study published in 2012 concluded different rainfall events that produced measurable runoff in 2007. Approximately 1 centimeter of rainfall was required to produce a measurable runoff, although this was highly dependent on soil moisture and the time between rainfall events. The hormones found in the runoff were aldosterone, progesterone, estradiol, and testosterone. Another study in Florida was done in 2002 when biologists were examining fish that were downstream from a feedlot. They noticed the changes in the fish sexes and started to piece together that these changes were due to the hormones in beef cattle. One scientist noted, quote, "When it comes out the tail end of the cow, we haven't been interested," said Juliet. "Now we need to reconsider our assumptions." Beyond the United States. Beginning in 1981, the European Union started a ban against hormones. Scientific research commissioned by the European Union has concluded that 6 growth hormones used for growth promotion in cattle pose a risk to consumers. The adverse consequences include developmental, neurobiological, genotoxic, and carcinogenic effects. They did warn that of the various risk groups, prepubertal children were at the greatest risk. Not only will Europe not allow their cattle to be treated with added hormones, but they will not allow any meat to be imported due to the concern. Furthermore, Canada, Australia, and New Zealand do not allow use of BST in dairy cattle, but they have approved the use of hormones as growth promotants in beef cattle.
All in all, there's a chain of effect that occurs when we allow our food sold for consumption to be infused with hormones twisted with artificial elements. It begins with the animal effect. For example, in reference to earlier slides presented by Samantha, cows are prone to mastitis, which is inflammation of the mammary gland, which are located in the udder of the cow, as you see pinpointed on the slide. This conflict originates from an infection leading to effects on milk production, shown to the right. Next up on the chain of effect is the human population, also known as our consumers. It becomes concerning to consider how many hormones are consumed and how do they affect us humans, given that studies exemplify links to cancer and more. Next on the chain is the effect taken nationally. If the American civilians become affected, then the nation does as a whole, which leads to the concluding stop of the effect taken internationally. By infusing our meat products with hormones and additives and producing for the international market, the entirety global population becomes affected in the mix of consuming hormonal products, which affects, impacts, and raises concern for all.